Hello and welcome back. I am Matt Hohan, Captain of Operations here at Granbury Volunteer Fire Department. And at this point, I hope you actually know where you're at, and you're probably expecting me to give you an introduction real quick to what we're covering. And you'd be right. You're covering online training through Granbury Volunteer Fire Department's online Fire Academy. Today we're going to be covering Section 5, Salvage and Overhaul. Now, guys, I can assure you, for me, overhaul is just the worst part of the structure fire. All the fun's over with, and now we're just down to straight physical labor. But I cannot express enough at how important overhaul is for completely extinguishing the fire, but also the salvage function. Don't forget where you're at. You're at someone's house or you're at someone's business, and at the end of the day, that is their stuff. They called you to come in and protect or save or salvage their stuff. So you need to act accordingly to it. Here's the real benefit to it, and this is what I want you guys to really learn from this class tonight on salvage and overhaul. This is one of the biggest PR moves that you can do for your department. You will gain decades of good PR by doing good salvage and overhaul, or it can really bite you in the butt. Either way, sit down, be ready to take a whole bunch of notes tonight, because here we go, salvage and overhaul. The purpose of salvage and its value to the public and the fire department. Guys, again, this is a major PR move by the fire department. I could not tell you how many structure fires that I've been to, and we've been able to salvage the most basic things from an absolutely devastating fire, and the family thanked you. Now, items that you'll be asked to receive run the gamut. Typical things, jewelry, family photos, guns. I've also done salvage and tried to find gravestones that they've had at their house. Historical documents, government documents, personal documents. Again, the list is infinite as to what's physically important to the person. But if you can physically find those and return them back to the owner, it makes a world of difference for the owner, and they will never thank you enough. They will be so grateful. It is a critical portion of fire department operations. Yes, the person that had the emergency, they called 911. They're expecting you to show up, and to a certain extent, they're expecting you to be able to find their belongings. But when you have a house that's a complete loss, the entire structure is on the ground, and you're able to come back to them with their grandmother's jewelry, it's a world changer for those individuals. Always focus on doing a very good job of salvage, and the benefits and payoffs from it are just exponential. Folds and rolls as salvage covers. Now, this is definitely a skills night topic, but the one thing that I'm going to add to this is just a quick side note. You don't have to go buy the $300 tarps and put them on your fire trucks to have good salvage covers or tarps. You can go to Home Depot or Lowe's and buy big rolls and sheets of plastic. If you can think about it, if you ever have a structure fire that's a small fire, and the example I'm going to give you is a fire that's contained to the kitchen. Once you get a quick knockdown on that fire, get back outside, get some crews outside, and bring in your salvage covers, your tarps, and your rolls of plastic, and start covering everything. Because at this point, the damage that's going to be caused in that house is by you. You've just put a bunch of steam in the atmosphere. There's still a ton of smoke in the atmosphere, and just start covering everything up. Now, cover TVs, cover other electronics up. If you see any pictures or anything sitting out on tables or bedstands or just sitting on the wall, grab all that stuff, pile it up, put it together, and cover it up. Go out of your way to protect that stuff. again, the payoff is exponential, and the homeowner will be very grateful for the actions taken. And it's one of the simplest things we can ever do, and it's one of the most beneficial things that we can ever do on scene. And we'll go into how to actually group all this stuff together in a little bit. Salvage cover throws. Again, this is going to be done on the actual skills night. And I don't really have much more to add to this. You can just click for the next slide. Inspection, cleaning, and maintenance of salvage equipment. Now, sometimes you might have those big red expensive tarps, and if you happen to have those, after you've used them on a structure fire, the way you clean and inspect and maintain them is get them back to the station, stretch them out, and physically take soap and water and wash the tarp down. Rinse it off, roll the tarp over, wash that side down, hose it down, and then stretch it across something so it can air dry. The biggest thing that we're using these tarps for is just separation. We're going to throw it over something, we're going to cover it, and the purpose of that is just to keep whatever's under the tarp separated from whatever's above the tarp. So we're keeping the good homeowner's property separated from the smoky, humid atmosphere outside the tarp. We have to, when we're inspecting these tarps, we want to make sure there's no giant holes or burn holes or tears or rips in the tarps. As far as the holes go, one of the easiest ways to find it is physically just get under the tarp outside and just look for sunlight beams coming down and hitting the ground. Once you find a hole in the tarp, one of the easiest ways to address it, again, once it's clean, is just to take a piece of duct tape out and physically go over the hole in the tarp and cover it up. The other part when you're dealing with tarps is make sure you don't, after you wash them, don't just roll them back in a roll and throw them back on the truck, because they're just going to turn into a giant log of mildew. They need time to completely dry out before you fold them back up and store them back on your apparatus. Now, the purpose of overhaul, guys, is we've made entry into the structure, we've done a solid job of extinguishing the fire, and now what we're doing is that we're making sure the fire is completely extinguished and there will be no rekindles or the fire starts back up again. They're the same thing in an X amount of time. We only want to go to the house fire once. We want to extinguish it once, and we only want to call for help from our mutual aid departments once. I can assure you from personal experience on really bad house fires, it sucks when you have to go back out to that house fire again at 2 o'clock in the morning and then again at 6 o'clock in the morning, because the crews that are extinguishing the fires and doing the overhaul aren't doing a good enough job. Searching for hidden fires. This is the whole purpose of overhaul. You have this simple picture. It looks like guys are working on the exterior of possibly a garage, and it looks like they're in the process of pulling down an eave. You can see that there was a very serious fire here, because not only is all the outer wall material removed, but the only thing that's left that are studs, and they are burned very hard. Now, that outer eave, you could have potentially had the wall itself burning on the inside, so you have to physically remove the eave to even get to where the fire was at or where the hot spots are still at. There's a ton of work that goes into searching for hidden fires, and the easiest way to do it is once you've pinpointed where the fire's been burning, just start tearing things away from the actual structure until you get to the unburned surfaces. Once you've cleared an area and you have just a solid picture of unburned surface around it, your overhaul is complete. At that point, just continue to apply water until all the surfaces are cooled down. Exposures of hidden fires by opening ceilings, walls, floors, and pulling apart burned materials. Now, We talked very early in these online modules about the fire science, and we learned about the way heat transfer works through convection and radiation and conduction. And really, this is the fundamental part of what we're trying to expose. We're trying to get all the materials in the structure that were potentially affected by different aspects of heat transfer and get those materials opened up, exposed to the air, and cooled off. And we're going to open up ceilings and walls and floors, and we're going to pull the sheetrock up, and we're going to remove the vinyl flooring, and we're going to take the sheetrock out of the ceilings, and we're going to pull the wood paneling off the walls, and we're going to get into the walls, and we're going to physically remove the insulation in the walls. It's a very time-consuming and laborsome process, but doing it right means that you actually get the fire extinguished. Now, pulling apart burning materials or burnt materials. Just imagine a giant stack of clothes that's been on fire. Well, it's just the outer shell of the clothes that's going to be burning. The very inside stack of that clothes, that's not going to be burned. It may be superheated and may be this giant wadded plastic block that's stuck together, but we still have to use our tools and pull all that apart so that we can actually get the heat out of the stack of the clothes so it can actually get cooled off. And it's the same idea. If you have a giant wad of crap that's just stuck together and there's a lot of smoke and there's a lot of embers inside of it, you need to pull it apart. Get it apart, get it opened up, get it cooled off, get water on it. And unfortunately, the pulling apart burning materials, that's a gigantic list. It's everywhere. Insulation's always a problem. Objects in rooms are a real problem. Mattresses, couches, chairs, phone books, books themselves. Anything that's just a tightly compact material that's in just one finite space makes it very difficult to get that fire extinguished by just spraying water on it. You're going to have to use your hand tools and physically pull those materials apart. Separate and remove charred material from unburned material. If you have a small fire inside a house, part of our PR should be to help get that homeowner's house back in serviceable condition as quick as possible. So if you had a little old man or a little old lady that was making dinner one night and they had a relatively serious kitchen fire, but it was a small fire, go ahead and remove the burned materials from the inside of their house. They're still going to stay in their house for that night. And it may be Friday night when the fire happened, and work's not going to start till Monday. Get the burned material out of the house and get it outside. Now, when you're doing that, don't just grab handfuls of crap and then just create a firefighter chain and start handing it to each other. And now you have this big long soot trail where everything partially dropped on the floor until it finally got outside. Figure out a way to get a container or a vessel or a shovel or some other mode of transport so that you can move this stuff from inside to outside cleanly. Again, we want to do it cleanly and we want to do it as safe as possible as well, but we're doing this for the PR for the homeowner. Firefighters left at the scene for fire and security surveillance and identification, the proper procedures for restoring the premises after a fire. I'm going to talk about the security and surveillance part first. There are times when the fire marshal's office or the city fire inspector may ask the fire department to remain on scene. Now, the first reason for this is that once we clear the scene and we terminate command at that scene, we're effectively turning the property over to the property owner. And the investigation may require the investigator to come back tomorrow. And what we're going to do is remain on scene. That scene is still our scene, and we're going to hold it until either the fire marshal or fire investigator takes over. And once it's their scene, it's their determination whether they want to cancel command and turn the property back over to the owner, or they still may need it again for another day. They may need it for a month. They may need it for 3 years. Now, we're not going to sit out there for 3 years, but just realize that there are times where we will sit on scene long after the fire's been extinguished. Now, proper procedures for restoration of the premises after a fire. So the first thing we have to do is we have to make sure the building is safe. All right, if the building's half collapsing on itself and, half the wall's missing and 2/3 of the roof is burned through, that building's not safe, and we're not going to make it safe. What we're going to do, though, is we're going to put caution fire tape around that structure, and we're going to tell the property owner, don't go in there. And at that point, the property owner's responsible for making sure that they don't go in there and have the structure fall on them and kill them. Second thing, making the contents safe. This is another reason why you may leave personnel on scene for a while, and that's just to allow different residents for a large fire to show up and individually search the different parts of the structure for their property. Making the area safe. We may have to physically extend the protection area around the structure just for general public safety. Restoring fire protection systems. This will be a subject that we cover in a later class on fire sprinklers. Restoring utility services. Lucky enough for us, we don't do that. We don't restore water, we don't restore electricity, and we don't restore gas. There are utility services in Hood County, in Granbury, that take care of that. Securing the building. Now, this might be a reason to physically leave someone on scene, but at the end of the day, we're not security guards. If there's suspicious activity at a structure that we're watching over for the investigators, we may physically just call the police or SO to confront those individuals. Again, we're not Darkwing Duck. We're not too interested in securing the building and going after people that are acting suspicious. Deodorizing the premises. Okay, when structures are filled with smoke, the smoke has a tendency to stay there. We can use our ventilation fans to help push that smoke outside of the structure, and then ultimately releasing the premises. As a fire department, when we turn the structure over to the homeowner, we are not doing so with the intent of them being able to go in there and get hurt or injured or ultimately killed. If that structure is not safe, then we may not release the premises immediately to that homeowner or the business owner. Our intent is to keep our jurisdiction safe, and when we release those premises, we're allowing people back into the property, and that may not be something that we're interested in. Demonstrate the following skills: the use of a water chute, the use of a water catch-all, and then the construction of a water chute and construction of a water catch-all. You know what this sounds like to me? Probably skills. Removal of debris and removal of routing of water from a structure using the following techniques. Now, before we go through these different techniques, again, you got to remember, we are not doing this because it's easy or because it's awesome. We're doing this to help the homeowner or help the business owner out. Okay? We are after the PR here, and that is our sole objective. Now, water vacuums, those are pretty self-explanatory. Here's the problem. If you're standing waist deep in water and you're using an electrical appliance to remove the water from the structure, I don't really recommend doing that. Second thing, brooms or squeegees. Great example of this is that if you have a broken sprinkler pipe in a church and there's no fire, the sprinkler pipe just broke because it was old, or maybe it was freezing conditions and the pipe froze in the attic, you can use brooms and squeegees to help physically get that water out of the building. Use existing drains. Now, existing drains will typically get plugged pretty quickly with debris that's just on the ground, but just clearing the drains and allowing the water to drain through in-building drains is a fantastic way to get the water out of a structure. Buckets, mops, and shovels. That's the long, hard, and dirty way to start helping cleaning up a property, but it's also usually the most effective. Lastly, I know Granbury doesn't carry any, and I'm not even sure if anyone in the county carries any portable pumps. But if you have any small portable pumps, they're also really handy at helping to remove a ton of water out of a structure. Covering or closing the following building openings made during firefighting operations. So again, we're doing this to help the homeowner out. We're doing this to help the business owner out. How do you cover a hole in a roof? Okay. All the trucks here in Granbury, we have roof kits. And in this roof kit is real simple. There's a hammer, there's some nails, and there's some sheets of plastic. Is this the best option for having to patch up a house real quick before a hurricane? Absolutely not. Is it a solid option to put on a house for the homeowner having to wait for a contractor to wait and show up and fix a hole in the roof? Most definitely. Now, windows and doors. Assuming that that's not the only exit point of the structure, you can use sheets of plywoods. Have the homeowner buy one and just have them bring the plywood to us, and we can physically put up plywood over window openings and door openings really quick. And that's more than enough to just keep the basic elements outside of the structure. Now, floors gets a little more difficult. You can use a sheet of plywood to cover up a floor, but I really recommend at the point that there's major floor damage, I would really recommend that they just find a different way to actually secure the structure entirely and keep it closed until the hole in the floor's been fixed. There's a million different ways to cover up these openings. I've just given you a couple. Ask your department at what their preferred method is and go off of your department's procedures. Procedures to follow during overhaul. A big emphasis on overhaul, not just locally but nationally right now, is wearing your air pack during overhaul. Just because the fire is extinguished and just because most of the smoke is gone from the room does not mean that those materials in that structure are not still very hot, and does not mean that they are still off-gassing. The problem is that now that they're off-gassing and not burning up, and a firefighter's in that structure doing overhaul and not wearing breathing protection, what in the hell are they breathing, and how much oxygen is physically in that room? These are two major factors that affect firefighter health. And every year I hear several different stories of a firefighter critically injured in overhaul just because of the materials and exposure to hazardous and toxic gases inside the structure. Another way to really look at this is if you take a couch, and we know that it's made of a whole bunch of stuff, pleather, foam, glues, paint, coated metals, plastics, and we take that entire couch and we turn it into a gas, do we really want to breathe that? Do we even know what the hell those materials turn into when they're turned into a gas? Well, just a handful of those gases, and you may or may not be familiar with these, are things like hydrogen cyanide, formaldehyde, carbon monoxide, carbon dioxide. The list is extensive, and these materials are incredibly dangerous to your health. And the list is long as far as what your physical exposure is to various gases inside a structure. I know overhaul is hard. I know overhaul sucks. But for your overall health and ultimately your overall longevity, you have got to get into the habit of wearing an air pack during overhaul, because the exposure to the toxic atmosphere is still highly present, not to mention the low oxygen levels. This is something that you guys should really discuss in-house with your department, and this is a personal decision that you're going to have to make. You may have a crusty old guy, salty old guy in your department that refuses to wear an air pack during overhaul. Ultimately, that's their decision. It is your decision to either breathe the couch or to breathe the nice, clean, fresh air in the SCBA bottle. That's your decision. You make it. Precautions to be followed when overhauling targeted hazards. Maintain safety of firefighters and others during overhaul operations. First off, again, we just talked about wearing your SCBA. Wear your SCBA. Even if in this picture, this is a great picture, even if there's no roof on the structure, how many of those gases are heavier than air? If they're heavier than air, they're still going to be trapped inside that structure. Another thing to consider when you're doing overhaul is if you're using pike poles, New York hooks, chainsaws, axes, sledgehammers, pigs, Halligan bars, and again, an extensive tool list here, don't be just wildly swinging that crap around until you blindly stumble into someone's head or face with an axe. Maintain control and good tool use when you're actually using the equipment inside the structure for overhaul. Another thing to consider is your physical workload. Don't work yourself to death. If you're working yourself to death, how long are you actually going to be able to work inside doing overhaul? Not long. Take your time, do good work, and really watch the other people around you. Now, equipment and clothing for performing overhaul activities. Let's just go to the PPE. We're going to hammer it a third time. Wear your SCBA when you're doing overhaul. Wear your PPE when you're doing overhaul. Again, it's a highly hazardous and toxic environment that you're in. I realize overhaul is hard, and I realize that you're tired, and I realize you're exhausted. The whole purpose of your gear is to protect you from the environment that you're standing in. You've got to wear your PPE. Now, equipment. You've got a full mantra of equipment to use on the truck, and they're all situational specific. That's more of a free-for-all for yourself to figure out. Lastly, hazards associated with overhaul operations. And I've talked about a lot of hazards, but one of the big ones I haven't mentioned is the structure is compromised. It just had a fire in it. So as you're doing overhaul and you start tearing walls out and you start tearing the ceiling out and you start tearing out different facets of where the fire dug into a corner and you start removing studs, don't forget you can compromise the building to cause it to collapse on you. And whether the building's burning or unburning, a building falling on you is bad. So you've got to watch structural integrity when you're doing overhaul operations, regardless if the fire is burning or not. You've got to watch for collapses, and you've got to be aware of where people are pulling things down so yourself doesn't get cratered or domed in the head by someone pulling a brick wall down to get to the fire behind it. There's a lot going on with the overhaul and the hazards, and we've just covered some of the finer points. If you have any questions or ideas on where other potential overhaul hazards are at, go ahead and write them down and bring them to class. Share them with everyone. Four indicators of fire in walls or ceilings. So here's my question. How do you think you recognize that there is a fire in a wall or in a ceiling? Go ahead and write your answer down. Now you maybe had written down some different examples, but I'm going to go over sight, touch, sound, and electronic instruments. You can physically see a fire in a wall sometimes by paint peeling off or by sheetrock degrading, or literally the materials outside the wall are getting so much conduction and radiant heat from the fire inside the wall, the materials outside the wall will start to char. Now another way is physically by touch. You can physically feel the heat coming out of the wall. It's kind of like standing next to a wood stove. You don't physically you don't physically see the fire, you're not physically exposed to the fire, but the fire is so extensive inside the actual inside the wood box that all that heat is radiating and being absorbed into the metal, and then it's radiating out from the metal, so you can feel it. Sound. You can hear a fire burning. You'll hear the popping, you'll hear the crackling. You can hear the fire inside the wall. Lastly, electronic instruments. Your thermal imager is worth $10 million when trying to find a fire inside a wall. It will pinpoint you to exactly where the fire's at. And this is all applicable to the same thing with a ceiling fire. Do you have anything else written down? If you do, share it with the instructors in the class. Restoration of the premises after a fire. Restoring the fire protection systems. This is something firefighters do very commonly, and I can tell you from personal experience and after running 1 million of these fire alarms here in Granbury, very, very exceedingly rarely does the person on site, whether they be the owner or a manager or whatever for the company, they do not know how to restore a fire protection system, and there's a really good chance in their efforts to restore the fire protection system, they're really going to screw it up. It is kind of a fickle job, and you truly have to know and understand the system. Again, we'll go through more detail on this on the night we do our fire sprinkler projects and cover alarms in more detail on that night. Secondly, restoring utility services. Good news here. It is not our job to restore electricity, water, or gas back to a structure. We will call the utility services to come back and restore those services to that premises. Now, the one thing to add here is on water, if you live out in the county and you physically turn the homeowner's water off for whatever reason, be the good guy here and turn the water back on for him if it's applicable or if the problem's been fixed. There's no reason in the world to force them to call a plumber at 3 o'clock in the morning. Third, deodorizing the premises. Again, about the furthest we're going to go with this is the ventilation. We're not going to run around with a whole bunch of air fresheners. We're not going to put some special sea salt in the carpet and vacuum it up. We're going to vent the structure, and that's about the lengths that we're going to go. Lastly, releasing the premises. More detail on this, obviously if there's an investigation in place, we may not want to release the structure immediately to the homeowner. Even if the homeowner's not suspected of anything criminally, the insurance company may dictate that the home or the property, the business, can't be turned back over to the homeowner until their investigators come out and physically look at the damage that was caused. There are plenty of other times where we're going to release the premise immediately back to the homeowner. This is more of an officer's decision on your department and should be punted to them anytime you're on scene. Hello and welcome to Granbury Volunteer Fire Department's online fire academy. And today we're going to cover Section 7 ventilation practices of SFFMA. Again, you're listening to Matt Hohan, Captain of Operations here at Granbury. And per the usual, if you have any questions, concerns, or comments about this class, you can always ask the instructors in your class, and definitely encourage you to ask your officers and fellow firefighters of your home departments. Without further ado, sit down, get comfortable, and enjoy. Ventilation practices is important. Principles of ventilation, and identify the advantages and effects of proper ventilation. Ventilation is something that's very, very critical to me personally and the type of firefighting that I do and my main concerns on a structure fire. I cannot emphasize this enough. I do not care about the physical object burning inside the structure. The only thing I care about is the amount of smoke and off-gassings that's coming as a result of that fire, and my ability to control the atmosphere, the smoke and the off gases. If I can control the atmosphere, or I at least understand the atmosphere, my safety is much greater enhanced and understood. Now, my question to you is, why do we want to vent a structure? Why do we physically want to remove the smoke and the gases from inside a structure? Write down your answer. What do you think that reason is? Again, we already know that fire spread is primarily managed through smoke. So if we can contain the fire to one room, and we can maybe set up a fan at the front door and open up a window in that one room and take all the smoke and all the fire gases created in that room and send it out a window in the same room to the outside atmosphere, do I have an immediate threat of that fire spreading throughout the house? The short answer is no. If left unchecked, then of course the fire itself is going to immediately consume the house in a given amount of time. But if I set a fan up at the front door, or if I cut a hole in the roof above the fire and allow the smoke and fire gases to go vertically through the roof, I'm going to be able to contain that fire in one spot. And if I'm able to confine that fire in one spot, and I'm able to control the heat, and I'm able to control the smoke, and I'm able to control the fire gases, I've greatly enhanced my safety. Another thing that I've eliminated from the equation, a flashover. The firefighter killer, the giant scary monster in the room. My ability to control the atmosphere is directly related to my ability to control the flashover and my ability to control the fire spread. And we're going to go in a lot more detail of that. And I hope your answer was something similar to mine. And if not, that's fine. Just bring it up in class, and we're going to talk in a lot of detail on the ventilation skills night. Dangers present and the precautions to be taken in performing ventilation. Basic size up. Now guys, as we get into size up, we're starting to get into some pretty standard junior woodchuck firefighting tactics. And size up is something that not just officers do. Size up is something that every single firefighter on that scene operating should be doing. And a basic size up is life safety hazards, and that's going to be acknowledging where the utilities are at. Is there any potential victims? What kind of condition is the structure in? How big's the structure? How big's the fire? Well, how bad's the smoke volume? What's our weather conditions? And on and on. Okay, our life safety hazards are all encompassing. Determining the location and extent of the fire. This is the true reason of the size up, the Firefighter 360, and why you know the structure. Determining the location and the extent of the fire is ultimately going to not only determine how you ventilate, but how you're going to physically attack the fire. And then lastly, identifying building construction features. Again, how can you ventilate the structure if you don't even know how the hell the structure is built? How are you going to be able to competently or safely do an interior attack if you don't understand the building construction features? This is something we'll talk a lot more in depth and in detail on the night we do building construction and smoke reading. But that's a basic size up. After the basic size up, a decision is going to be made. How you're going to physically attack the fire, whether it's an interior attack or a defensive attack. And then secondly, if it's an interior attack, how are you going to ventilate the fire itself and the decision to ventilate? Assessing the need for ventilation. Now this is entirely subjective. Let's go to a really small fire. Let's say grandma burning a pot of beans on the stove. Are we really going to break out 2 kitchen windows and, rip the window frames out, and knock in the front door and set up a fan and, vent the entire structure this way? Well, no. Are we going to go on the roof and cut a 4x4 hole in the roof and break all the shingles out and break all the ceiling out just so that the bean smoke can go up? Well, no. So again, assessing the need for ventilation, the physical size of the structure is going to have a lot to do with the type of need of ventilation, but also the physical size of the fire. Now, deciding where ventilation is needed. Personally, I am a horizontal vent option only kind of guy. I don't like vertical ventilation, and I'm going to go in a little more detail on vertical ventilation in a few more slides, but I will always do horizontal ventilation. It's just how I prefer to do it. And again, we'll go into horizontal ventilation in more detail in a few more slides. And then deciding how ventilation should be accomplished. Just because we're doing horizontal ventilation doesn't mean there's not more than one way to horizontally ventilate that structure. And a lot of fire crews forget about basic ventilation ideas and concepts when they're ventilating. Opening various types of windows from inside and outside with and without fire department tools. Guys, being able to figure out how to open something sounds kind of blatantly obvious, but if you're in a high stress environment, high workload, and low visibility, opening something as simple as a window can be a real pain in the ass. Now, one thing I want you to never do when opening something like a window from the inside or the outside is don't ever use your hands like Bruce Lee to punch through the glass. True story. I know of a firefighter that broke his hand trying to do this, and he was certified dumbass. You gotta be careful. Some of these glass windows are incredibly strong, and I assure you, just limp-wristing punching it isn't going to break the window, but it is going to do a hell of a number on your wrist. Here's another thing to consider. The glass. What happens if you actually do break the window? What's going to possibly stop the glass from coming through your glove and stabbing you in the hand? At least the window's ventilated, but now you have a hand injury. Now, I highly recommend using the department tools. Nothing really does get much better than just taking the old pig and throwing it through the window. Obviously, you need to hold on to it. We don't want to just throw the tool out the window and smoke someone that's walking by in the head. But it's a real quick option for getting a fast ventilation point. With that said, if we're talking about grandma's beans on the stove, don't just take the pig and throw it into the window and shatter it. We got to know and be competent on various types of windows and know how to open them. If you guys have any questions or concerns on this, definitely ask the instructors or ask inside your home departments. Breaking window or door glass and removing obstructions. Okay, now really down to the nuts and bolts of why breaking doors and windows and what's so important about it. This picture really just tells our story here. You have a firefighter that's crawling into a smoky environment on the second floor. You can see his thigh dragging across the bottom of the window. When you break a window out, you don't just shatter the glass and walk away. Once the window's broken, you finish your job and you break the rest of that glass all the way out around the frame. And the way you do that is you can take your tool and just put it on the edge of the frame and run it up and down the edge of the frame and break the rest of the glass out. Here's the other part of this. Also consider breaking out the second window and removing all the glass from it. The last consideration that I'm going to give you on a window, and this is a really good example of it, notice how that firefighter left that middle window frame there. And how hard is it going to be for that guy to potentially maneuver around that window frame? If he's in a big damn hurry to get out of that second floor, that window frame could potentially be a problem. Take the extra few seconds and remove the frame. Get it out of your way, give you a larger point of egress and make it 10 times easier to get in and out of that opening. Using both hand and power tools, the ventilation of a roof and a floor. Alright guys, we're going to go into a lot more detail on this slide on vertical ventilation and the why I don't like vertical ventilation in Hood County or even in the state of Texas. And a lot of it has to come down to just straight building codes. Your structures in Texas are not built to the same standards that they are nationwide. And if you look where vertical ventilation is really popular, Northeast, Midwest, and down in California, they build structures completely different than to how we build structures in Texas. And the reason for that is that in the Northeast and the Midwest, they build structures for snow loading. And those structures have to be significantly reinforced to be able to handle the weight of snow from a large snowstorm. In California, they're building structures in building codes for requirements for earthquakes. In Florida, they build structures in accordance with the approaching hurricanes. Here in Hood County, we just don't have a vast variety of natural disasters here other than a tornado, and we're not going to tornado-proof a structure. It's just not in the cost benefit of building a house to live in. And at the end of the day, your building codes here in Texas are generally very light material construction oriented. We're not building for snow loads, we're not building for earthquakes, and we're not building for a million other factors. And because of that, vertical ventilation is by far my least favorite option for vertical venting or for any ventilation process. And again, it's because the building is not built to have any rigidity for weights on the roofs. On top of that, the stronger the building is built, the more damage it can take from things like a structure fire and be able to hold up longer. Now, back to the actual ventilation of the roof with a hand tool and power tool. We'll talk about this in the class and we'll demonstrate how to do it. You can use an axe, you can use a pig, or you can use a simple chainsaw. And we'll physically talk about how to ventilate those roofs. Floor operations, a second-story floor or maybe a one-story floor down to a basement, operate on the same principles as far as vertical ventilation. And we'll go into detail in the skills night on how to perform those tasks. Ventilation using a water fog pattern. I'm a big fan of hydraulic ventilation. It is a great way to approach a real small fire, make an interior attack, snuff the fire out real quick. Now you're going to have a smoke and gas and steam buildup in the room. Open up a window, stick your nozzle out the window, go to full fog, and there'll be a massive volume of air that's moving through that room, and it'll be ejecting the smoke and vapors and gases out of that structure. We'll demonstrate this on Skills Night, and you'll see how powerful of a tool this really is. Precautions when ventilating the following types of pitched roofs. Now, these are a whole bunch of different types of roof constructions, and I'm actually not going to go through this list. I'm going to save it for the building construction night. The one thing I want you to seriously take into consideration is old construction versus new construction, and then ultimately, how good was the carpenter that put the house together? New construction is incredibly light materials, and really frankly, any house built after 2010, if it has any type of substantial fire load in the attic space, it should automatically become a defensive fire because that structure is so critically threatened at that point. It's actually scary, and you'll understand that a lot more when you get on scene and you start to see the materials that they're physically using to construct these buildings. But a great example I'm going to give of this is here in Granbury. If you go to Chipotle, to be cool and hip and modern, they actually left their entire truss structure and rafters available for the public to look at. And next time you're in there, or even take a field trip in there and go look at how those trusses are actually held together. Tell me where the hell the actual nail is at that holds that wood together. You're going to see there aren't any. All of those trusses and rafters are held together with just metal plates that simply just lay on the wood. They're about a ½ inch long, and then you just beat on it with a hammer and you tack the wood together kind of in a Lincoln log fashion. At the end of the day, there's nothing holding that structure together other than those plates. But here's the kicker. Guess what the melting point is on those plates? It's incredibly low, but at least the plate itself, the little nails that stick out on the plate, they don't actually go through the wood. All they do is barely penetrate the surface of the wood. So the second the actual timber itself starts to burn, well, what is burning? It's the outside layer of the actual lumber. So you've got two factors of failure that are almost instantaneous in their catastrophic effects on these structures. Again, we're going to go into a lot more detail on roof types and constructions in the building construction class. Size and location of an opening for ventilation and the precautions to be taken during ventilation. Again, we're talking about vertical ventilation here, and the first thing we're going to talk about, and before I forget about it, is just the size of the opening for vertical ventilation. And a simple rule of thumb, if it's a residential fire and you're vertical ventilating, you need a 4 foot by 4 foot opening, and if it's commercial, 8 foot by 8 foot. Now, existing roof openings. We're talking about things like the whirlybird vent exits, potential chimneys, and then if you get on the commercial side, I think things like Walmart and Home Depot and Lowe's, they also have, I'm getting inundated by text messages, sorry. Walmart, Home Depot, and Lowe's, they also have a smoke detection and heat sensing system that detects a large fire, and they actually have portals in the roofs that automatically open up. And those are intended vent sources for that structure. Now, the location of the fire. This is the great debate. I'm not a big fan of venting directly over the fire. I like to vent just outside of directly over the fire. That way, if I ever happen to fall through the roof, I don't actually fall into the fire. Kind of an important little detail there. With that said, if the fire's on one side of the house and you vent on completely the other side of the house, which way is the fire gonna go? We know that fire's gonna follow smoke, and smoke's gonna take the path of least resistance. You are going to unintentionally catch that house on fire exponentially faster, and you're going to make it a lot bigger of a fire simply by venting from the wrong spot. So you need to make sure that you know the location of the fire so you're venting in the proper spot. We just talked about direction in which the fire will be drawn, types of building construction. This is really important. If you have a 2-story house fire and the fire's in the attic space above the second story, don't cut the roof on the 1-story garage. It's not going to work that way. Smoke and heat's not going to go down, it's going to go up, and vice versa. If the garage is on fire and you cut a hole in the 2nd story above one of the bedrooms, which way's that fire potentially going to go? Especially if it happens to burn through the wall and get into the wall of the structure. You've just created an expedited pathway for that fire to grow exponentially and get 10 times worse. Now, wind direction. This is absolutely a huge factor. The wind will significantly impact your ability to ventilate, horizontal or vertical. And you don't ever want to vent on the windward side. That's where the wind is coming from. You don't want your vent hole facing the direction the wind is coming from. You want it on the downwind side. You want the wind to be blowing across it. You don't ever want the wind to work against your vent point. You want the wind to assist your vent point. The physical progress of the fire. I assure you, if the entire roof space and it looks like the entire attic space is on fire, don't get on the roof. There's a certain point at when the fire is just too big and we have no business doing vertical ventilation. The physical condition of the building, and this is a true factor. If you know that that's an abandoned structure from 1830 and there's no one in there, what the hell are you getting on the roof for? Now, if it's a modern structure and firefighters need to make an interior search for possible victims, then I can understand the actual need for doing a vertical vent. But if the building is in dilapidated state, already self-collapsing, or already had such substantial fire damage that it's starting to collapse on itself, don't get on the roof. Now, the safety precautions are numerous, and I've talked about a lot of them, but there's more to even be mentioned. Let's look at the top right picture really quick. You see two guys working on a really steep pitched roof. I want you to look at the firefighter with the chainsaw in his hand, and I want you to look at his right foot. If you notice, he used an axe as a foothold. That's because he has to physically get out to where he's cutting on the roof to be able to safely cut a point in the roof. Without that foothold, how much more of an exposure does he have on the potentially falling off the roof? And lastly, relative efficiency of a large versus small openings. Now, I told you at the very beginning of this that you need a 4 square foot for residential and 8 square foot for a large commercial or industrial. That does not mean that it has to be 8 feet by 8 feet or 4 feet by 4 feet. Why not do a 2 foot cut 6 feet long, or a 3 foot cut 12 feet long? These are approximate sizes. You're just trying to get a hole at the high point of the structure to get the fire and gases out of the structure. You're looking for ballpark sizes. I'm not expecting you to be up there with a tape measure and have this thing down to the nanometer as being as accurate as possible. If all you can cut is a whole bunch of little holes, then that's all you can cut. If it's easier to cut one big hole at one time, then do that. Again, we're looking for speed versus time on the roof versus overall safety. We are considering these factors on vertical ventilation because your butt really better be good at vertical ventilation, or you better be with someone that truly understands vertical ventilation if you're on a roof. There's no time to screw up. Natural and mechanical methods for horizontal ventilation of a structure. I'm going to talk in great detail on this slide, and there's going to be several points where we're going to pause. I'm going to ask you some questions, and then we'll kick the slideshow back off. Horizontal ventilation tools and equipment. The biggest thing that you got to realize in horizontal ventilation is that you have to pick a point at where your vent process starts, and then you also have to pick a point at where the ventilation process is ultimately the exit point. And our tools that we typically use for ventilation is going to be a small but very powerful fan, again, typically placed on the upwind side. We want the wind to also be helping our ventilation going into our vent point. And then our exit point is typically going to be a point that's downwind. We want the wind and the fan to both assist on clearing the smoke from the structure. Now, sometimes we're going to be setting up at the front door, so there's no tools required to create an entry point. And then sometimes we have to physically create an opening for us to set our fan up into, and that's fine. Now, our exit point. I really recommend using doors and windows. It takes the least amount of time. I have yet to ever be to a residential structure that doesn't have doors and windows. And that's what we should be using for our entry and exit points for ventilation. And our tools and equipment, just a standard complement of that fan, and then just basic hand tools. Now, structural characteristics of buildings which aid in natural or mechanical ventilation. Scuttle hatches, bulkheads, skylights, monitors, light and ventilation shafts. I want you to think about and answer this question. What do you think that's inside a structure which will help us in the ventilation of that structure? Go ahead and write down what you think will help us, and we'll come back. Structural characteristics of a building which aid in natural or mechanical ventilation. Now, I know you've written down at least one, but here's one of the basic ones, and I'm willing to bet that you never wrote this down. A door. If the fire's contained, let's say, one bedroom like it is in this picture, okay, there's no reason in the world to not close the door to the other bedroom. We've just compartmentalized that entire structure, and we've decreased its total size by 25%. Our ability to physically control the structure by compartmentalizing it and opening or closing doors as we see fit will greatly enhance our ability to not only control the fire inside the structure, but also to be able to control the atmosphere through ventilation. Now, obstructions to horizontal ventilation. One of the absolute worst are screens. Screens are the absolute vein of our existence when we're physically trying to vent a structure. Screen doors and screens on windows. And I've seen various numbers on how much a screen will restrict airflow out of a structure, and the most common number is between 85 and 90%. So you've done all this good work to only have a screen be the last thing in place that's physically stopping all the smoke and fire gases and heat traveling out that window or door much more effectively. With that said, remember, some of these screens that are on houses are incredibly expensive, and if you just start ripping them off or pull out a pocket knife or get a set of cutters and you start cutting all this stuff up, that homeowner could be straight up living pissed with you if you continue to just destroy their property. Obviously, if there's a great need and you need to quickly get that off right now, then you're going to have to do what you have to do. But I can also tell you that you can take a few extra seconds, if not that long, to take the screen off properly and actually save the homeowner a ton of money, because they're not going to have to replace those screens. Now, weather conditions which affect horizontal ventilation. And we've talked about this. We've talked about the wind, but the one thing I want you to consider and that you don't know is that how much do you think your fan is restricted by blowing against the wind? So my question to you is your fan is just going all out. It's screaming. It's running full out. How many miles per hour does the wind have to blow to completely negate the effect of your fan? Write your answer down and we'll be right back. How many miles per hour does the wind have to blow to counter your fan? It's about 8 miles per hour. So if you have your fan set up at the front door, and that is the downwind portion of the fire, but you at least have the vent point on the upwind part of the fire, what's going to happen is the force of the wind and the force of the fan are going to counteract each other, and what you're going to be doing is potentially setting up a blast furnace, and it's going to be making conditions exponentially worse on the inside of the structure. And here's why. Since no smoke and no heat and no fire gases are leaving the structure as intended, and they're being trapped inside, typically that event is going to snuff out the fire because it's going to consume all the oxygen in the room. But what is the fan doing? The fan is guaranteeing that oxygen's getting into the structure, and it's allowing the fire to burn uninhibited, just like a blast furnace. So if you set this up wrong and the interior crew makes an interior attack at the front door, as soon as they get inside and they get close to the fire conditions are going to be absolutely atrocious. And they're going to be atrocious and just simply terrible because of the conditions set up by the firefighters themselves. Good placement of fans and good awareness to what the weather's doing is going to be a huge benefit to you. In that exact scenario I gave you, when you set this house up for ventilation, and we're just going to say that this is, and we're going to look at our picture, the front door is one of the furthest points away from the actual fire room. And if we look at our picture, we can see the room that's on fire actually has 2 windows. Is there anything wrong with breaking the upwind window out? Okay, so the wind is going to come out that window and then break the other window out on the room, which is on the side of the structure. Is that room going to ventilate? The answer is yes, and it's going to ventilate really well, and the wind is going to be doing all the work for you. All you had to do was break the window out, remove the glass, and make sure the screens are out of the way. And that structure is going to ventilate excellent. That fire crew is going to have a very easy time making their approach to that fire, and they can even go as far as just getting the door closed to the physical room that's burning so that you don't have any smoke or fire gases that's coming out towards the front door where the point of entry is at. That gives the crew that's dragging the hose up plenty of time to finally get up there, open the bedroom door, spray a bunch of water in there real quick, let the steam do its conversion, and close the door back. Let the fire and the water extinguish itself. Let the ventilation factor of the wind helping you push all the smoke and fire gases out of the room. Now, back to the real world, it's not going to work that simply, but I can guarantee you, by using ventilation by Mother Nature itself to assist you, it'll make a huge impact on how successful that you extinguish those fires. And vice versa, if you let it bite you in the tail, I assure you it will. There has been plenty of firefighters killed by not paying attention to the weather, and there's been plenty of firefighters that have burned down hundreds and hundreds of structures because they made entry on the wrong point of the structure, and they brought the fire to them and not away from them. Pay attention to ventilation because it's a huge benefit to you. Removal of skylights, scuttle covers, and other covers on rooftops. Now, if you look at these 2 pictures that we have here, what this slide's truly trying to address is flat roofs. If you're doing roof ops on a flat roof, an easy point of ventilation is physically knocking out the skylights, the scuttle covers, and any other type of ventilation point on the top of the roof. Now here in Texas, a very common structure that's on most rooftops, and this is also a major factor in determining if you're going to be doing an interior attack, much less roof operations, are these gigantic commercial air conditioners that are on the roof. And once those air conditioners have been identified, basically all fireground operations cease to exist from an interior attack point of view. The structure is not intended to be compromised by heat, and the potential of that unit coming through the roof and killing you, injuring you, or scaring the hell out of you is very likely. But on older structures, they may have smaller air conditioning units or may not even have air conditioning units on the top of the structure. And in this case, going after skylights and scuttle covers is a great point of ventilation for these structures and shouldn't be forgotten. Equipment used for forced mechanical ventilation. Fireground situations where forced ventilation procedures may be required. What we're talking about, forced ventilation, is using the ventilation mechanically through fans and using the ventilation process is part of the fire attack. Now, positive pressure ventilation is, again, setting the fan up at the front door, sending a stream of air in, a high pressure volume stream of air into the structure, and having a physical vent point outside of the structure so that all the heat, smoke, and fire gases are going out that vent point. Negative pressure ventilation is taking that fan, putting it inside the structure, and using it as a smoke ejector. You're sending all the smoke outside of the structure. And you might consider that particularly on a very large structure, something like a Walmart, a Home Depot, or a Lowe's. Instead of trying to figure out how to get X amount of fans outside of the building to shoot into the structure and pressurize the building, you're going to use the building size to your benefit. Take 2 or 3 fans inside the structure and set them up so that they're shooting out the glass doors, and what you're creating is a massive negative pressure inside the structure. So even though the fans themselves are only moving a generally small amount of air, once that volume of air starts to move, and there's a stream of air set up with that, once that stream of air starts to eject out of the structure, you're moving an exponentially gigantic volume of air out of that structure by just doing negative pressure ventilation. Now, placement of gasoline or electric powered fans to effective pressure. I really screwed that up, and I'm sorry. We're going to try that again. You'd be surprised at how long these slideshows really take, and I'm going to try and do this one without deleting this slide. Placement of gasoline or electric-powered fans to effective positive pressure ventilation. I still screwed it up, but if you were reading along, you're laughing at me, and everything's fine. The placement of our fans is what's going to determine how successful we quickly extinguish that fire. I can't emphasize this enough. You screw this up and you're going to burn that house down right now. You do it right, not only are you going to extinguish that fire really quick, you're going to look like the hero in the process because you're going to minimize a massive amount of damage to that structure. Now, I want to talk about gas and electric fans real quick. The benefit of a gas-powered fan is it's highly mobile and it's highly portable, but at least it gives out a huge volume of air. The consequence of it is it still runs off a gasoline motor, and it's going to give off noxious gases. It's going to give off carbon monoxide and carbon dioxide, and both of those are not a benefit to human health. An electric fan doesn't have the health factors associated with it, but at the end of the day, it's physically attached to the truck on an extension cord, so you're limited to how far you can physically take the fan. The placement of those fans are going to impact the structure regardless. Your ability to understand the placement of those fans is what ultimately determines the outcome of that fire. That is the end of this slideshow. If you guys have any questions off ventilation, please ask the instructors in the class, and I highly recommend that you talk about ventilation with your home departments. There is a lot of new firefighting tactics that are coming out that are starting to be utilized nationwide from ventilation. I'm a big fan of a positive pressure attack. I've done it on several structure fires myself. It is an incredibly useful tool, and you can put out a hell of a lot of fire very safely and very quickly, and you'll save the homeowner a ton of property. It's a fantastic firefighting tactic if used properly. Again, you screw it up and you have the potential to not only burn down their house really fast, but you can also put yourself in a position where your own life is at risk.